Hello everyone. In this video, we are going to discuss the problem 4.1 from the unit 4 Chemical Bonding and Molecular Structure, class 11 Chemistry. See, the question is, write the Lewis structure of carbon monoxide molecule. So let us see the steps to write the Lewis dot structure. Lewis structure in the sense Lewis dot structure of a particular molecule. Here we have to write the Lewis dot structure of carbon monoxide molecules. Let us see how to write it. So you have to follow the three steps. The step 1 is count the total number of valence electrons. So you see, in the carbon monoxide molecule, we have one carbon atom and we have one oxygen atom. See, the atomic number of carbon is 6, atomic number of oxygen is 8. So when you write its electronic configuration, it will be 2, 4, and for oxygen, it will be 2, 6. Okay, now you see, what about the total number of valence electrons? You see, carbon has 4 valence electrons, oxygen has 6 valence electrons. So total number of valence electrons will be 4 plus 6, which is equal to 10. So total number of valence electrons is equal to 10. Okay, now step 2. Draw the skeletal structure. How can we draw the skeletal structure? You see, when you compare this carbon and oxygen, carbon is least electronegative and oxygen is most electronegative among carbon and oxygen. So, you have to place carbon at the center, then oxygen around it. Okay, here we have only 2, so there is no meaning by saying it as center. But anyway, if there are more than 2 molecules, then you have to place the least electronegative atom at the center, then most electronegative atoms around it. Okay, so carbon is here, oxygen is here. Now, let us see the step 3. Connect atoms with bonds, single bond, double bond or triple bond. So start by connecting these two atoms, oxygen and carbon, using a single bond. Okay, see, I'm just drawing one single bond here. See, a single bond uses 2 electrons. There are total 10 valence electrons. A single bond uses 2 electrons. So how many remaining electrons are there? Total 10 valence electrons are there. When we use a one single bond between these two atoms, a single bond uses 2 electrons. So 10 minus 2, which is equal to 8 valence electrons are left now. So remaining electrons is equal to 8. Now complete the octet. When we complete the octet, you see, oxygen needs 8 electrons to complete the octet. See, this is oxygen. It needs 8 electrons. So you see, the single bond uses 2 electrons. So oxygen needs 6 more electrons around it to complete the octet. So 2, 4, 6. Okay, so octet or 8 electrons is completed for oxygen. So 6 electrons are used here. So 8 minus 6, which is equal to 2. So 2 more remaining electrons are there. Okay, so you see, place the 2 electrons around the carbon. So 2 electrons here. Alright, but you see, for carbon, this is not enough to satisfy the octet. Okay, because see, here the single bond does not satisfy octet rule or octet condition for carbon. Why? Because you see, for carbon, the single bond uses 2 electrons. Now 2 electrons are here. So 2 plus 2, only 4 electrons are there around carbon. So octet is not completed for carbon. Okay, so here the single bond does not satisfy the octet rule for both the atoms. So we have to form a double bond or a triple bond. Now you see, I have just written this C here and O here. No problem, only 2 atoms are there. No. So the single bond is not enough to satisfy the octet rule for these 2 atoms. So we are going to try the double bond. So I am just drawing a double bond between carbon and oxygen. A single bond uses 2 electrons, so double bond uses 2 into 2, 2 plus 2, which is equal to 4 electrons. So when total 10 valence electrons are there. When we consider a double bond between these 2 atoms, double bond uses total 4 electrons. So 10 minus 4, which is equal to 6 electrons are there remaining. Okay, remaining number of electrons is equal to 6. Now we have to place these electrons around carbon and oxygen. See, for oxygen, this double bond uses 4 electrons. So it needs, actually oxygen needs 8 electrons to complete the octet. So 4 electrons are here in the double bond. So 4 more electrons. Okay, so 2, 2, 4. So for oxygen, 2, 2, 4. Then single bond uses 2. This single bond uses 2. So 2, 2, 2, 2. Total 8 electrons are there for oxygen. So now oxygen has 8 electrons. So octet is completed for oxygen. Okay, so we had actually 6 remaining electrons. 4 electrons are used here around oxygen. So now we have the remaining number of electrons as 2. Okay, so we are going to place this 2 electrons around carbon. Now when we consider this carbon, this double bond uses total 4 electrons. Then 4 plus 2, 6 electrons. So for carbon, only 6 electrons are there around it. So octet is not completed for carbon. So now let us try a triple bond between carbon and oxygen. So I am just drawing a triple bond between carbon and oxygen. That is, we are connecting these 2 atoms by a triple bond. A single bond uses 2 electrons. So triple bond, 3 into 2, 6 electrons are used. Total number of valence electrons 10. 6 electrons are used here in the triple bond. So remaining number of electrons, that is equal to 4. Okay, now when you consider oxygen, 2, 2, 2. So 6 electrons are here in the triple bond. So 2 more electrons are required. So I am just placing 2 electrons here. So total 4 electrons were there. 2 electrons are used here. So now the remaining number of electrons, that is 4 minus 2, which is equal to 2. I am going to place this remaining number of electrons around this carbon, because you see, for oxygen, octet is now completed. Because 2, 2, 2, 6. Then 6 plus 2, 8. Octet is completed for oxygen. Okay, now we have 2 more remaining electrons. I am going to place it around C. Okay, now you see carbon has a triple bond here. So 6 electrons plus 2, 8 electrons. Okay, so here octet is completed for carbon 2. So now carbon and oxygen each share 3 pairs of electrons, that is total 6 electrons, and a lone pair for carbon as well as a lone pair for oxygen. This lone pair, which is a non-bonding electrons. Okay, so you see octet is now completed for both carbon and oxygen. So now this is the Lewis structure for carbon monoxide molecule. Okay, the Lewis structure for the Lewis dot structure for carbon monoxide molecule is this. I hope it is clear to you. Thank you.